gonna solve another example um, on working with exponential growth. In this example, we have a population of rabbits. We know that they're growing exponentially. In the year 2000, the population of rabbits was 940. So at the very beginning, we have a population of 940. And later on, after 5 years, in the year 2006, the population has grown to 2050. We are looking to find the growth rate. Okay, I want us to remember that growing exponentially is very similar to compound interest. So they follow the same principles and the formulas look pretty much identical. Sometimes we use different letters, but it's pretty much the same formula. So what's the logic here? Let me write down the formula. We say that the population that we have after a certain amount of time, just like the money that we gain after a certain amount of time, equals to, so I'm going to write population, and I'm going to write down the year, very small, right next to P, the population in year 2006, which is the final population, equals, well, it comes from the population that we had at the very beginning. In 2001, we had our initial population, and we need to multiply that by 1 plus the growth rate, which we're not sure what it is, to the power of the time that has basically passed. In this scenario, we're just measuring 2006 and 2001, that's 5 years together. I want you to take a moment to compare this formula to the formula of compound interest and see how similar they are. We also have the principle right here. We have the final amount here, 1 plus r to the power of t, also stays the same. I'm going to replace the 5 with a t just because this is my initial formula. I'm going to replace all the values right now. All right. Population in 2006, or the final population, is 2050, and that equals population in 2001, which was 940. We are multiplying that by 1 plus growth rate. I'm not really sure what it is. Let's leave it at r to the power of the time that passed by, or 5 years. We will solve this by isolating the growth rate, or r. To isolate that, we have to remove the factor that's been multiplied to the parentheses, the one that has been added to it, the power of 5 that it has received. We're going to start with 940. It's being multiplied to our parentheses, therefore we need to divide both sides by 940, here and here. I prefer not to do any calculations just yet, because usually for questions like this, we're allowed to use a calculator, but also I don't want to spend time on my calculations right now. 2050 divided by 940 equals, now I'm only left with my parentheses, 1 plus r to the power of 5. Well, I can't really touch that r right now because it has a power, therefore let's remove the power. How? By doing the opposite of having a power of 5. And that is to take the fifth root from both sides. What's going to happen is that this index of 5 right here cancels out the power of 5. And we're going to be left with the fifth root of 2050, 940, and that equals to, I'm only left with my parentheses, which is 1 plus r. Okay, the last thing we need to do is to subtract 1 from both sides. Let me write it over here. R equals fifth root of 2050 over 940 minus 1. When he asks us what is growth rate per year, I need to answer this right here. I'm gonna put that inside a scientific calculator. I'm looking for a fifth root of 2050 divided by 940. Outside, I'm gonna need minus 1. I'm gonna need another parentheses multiplied by 100. Just want to make sure all the parentheses are in order. Excellent. We like to express growth rates just like interest rates in terms of percentages, and here we have 16.875 and so on percent. Let's write that down, and we'll be rounding it to the 10th place. So 16.87 rounds up to 90. Okay, that's for part A.